Okay, so first, welcome to ee105. So you know the title of the course is Microelectronic Devices and Circuits. I'm Professor Clark Nguyen, so I'll be your professor for this semester. I've taught this course once before in fall 2018, and that went pretty well. I think it's a very useful course. I would say it's one of the courses that you must take if you really want to call yourself an electrical engineer. Because circuit design is one of the things that all electrical engineers ought to know. So this is kind of a must-take. It's also a course that you need to take in order to go on in circuit design and device physics, which are courses like 130, 140, 141. So this is kind of a leader course for that. Today we're going to do a lot of administration on that sort. Maybe we'll get into some actual material, but I'll at least go through the whole schedule that we'll have so you'll know what kind of material is going to be in the class. I guess first thing to address, why do I have two of these on the screen? It's better for memory is one thing, right? You see two of them like that, but the real reason is that when you're teaching a course in circuits, what you like to do is keep the circuits up and then derive different things based on that circuit. And so when we used to use the blackboard, we could do that very easily. Keep a circuit here, do all the other derivations there. With a computer screen, that's more difficult to do unless you have two of them. So what I do is I take the one screen we have there, split it in two, and so what will happen is maybe the circuit will be up on the left and I'll be deriving on the right. Okay, so hopefully everything is very visible to everyone. This should be very visible if you're way in the back, but let's see what happens when I do this. How's that? Can you see back there? Okay, good. So today, again, a lot of announcements and that sort of thing. So this is me. Just a couple things I'll get through first before introducing the rest of the staff, which I'll do when I go through the course outline. But all lectures are going to be recorded by both ETS, which should be recorded automatically right now. And that's why I put this thing on right here. And also, I'm recording it myself using my laptop computer here. You saw me start Camtasia in the beginning, so I'm recording that. I don't know which one turns out to be the better recording, but there's always a chance that some of the recordings don't come through the way that we're doing it. So yes, this course is being recorded, but if you want to miss lectures, do it at your own peril, because not all the time do the recordings get done correctly. All right. The other thing to say about the recordings is that you think you're going to watch the video if you haven't gone to the lecture later on, but chances are you won't. And the reason for that is because you get busy, especially towards the end of the semester. Right? You miss one lecture, you got to do your lab for the other class, you got to do a project, homework's due or something like that. So don't rely on the videos. The other way that maybe will help you with that too is that the videos won't be ready until about 2 days later. So definitely the ETS is not going to come online until about 2 days later. And my videos also won't come online until about that time as well, because when you record in Camtasia, you can't just put the Camtasia file up for streaming online. You have to convert it first to another format, and that takes a long time. Okay, and then I also put that up on YouTube by the end of that. So I guess I'll say we're recording the videos for you, and that's basically for your ability to go back and see lectures, but try to come to lecture. Definitely come to lecture, because you don't want to fall behind in this class. And I think you know this for all your other classes too. Now, in addition to the video, I'm going to post the PDFs of lectures. So when I do these lectures, I'm doing them all by laptop computer using inking. And so everything that I do in lecture is going to be in a PDF file, which I'm going to put online for you as well. Handouts also will be in PDFs online. And I guess that's most of the logistics having to do with the lecture and PDFs. Now, there is a website for the class, and I guess let me pull that up right here. So that's a little small there. But okay, I'm not online, so you'll have to get online yourself. But this is the website right here, at least in a widescreen format here. This has all the information for the course, but in addition to this, this is where we're going to put up lecture notes. So this is the lecture note table. So this lecture it's right here. This is the date. That's the lecture number. These are the handouts I'll go through today. If I write anything down, actually I already have some things written down, so I will put a PDF file up after the lecture. That'll come almost immediately after the lecture, at least within a day. And then the video will show up right here, just a link to the video, but that won't show up till maybe a couple of days. Okay? Also on the website, this is where we'll put your labs. So you have no lab happening until a couple of weeks from now. So all that's up there is the instruction manual. You can download that and read that. That's a PDF file that goes through the types of equipment we have in the lab, other logistics and that sort, and other things, right? So there's a homework link up here as well. You don't have a homework yet, but that's coming this Friday. You get your first homework assignment. Okay, and everything will be up on this website. So I do not use B courses. Okay, I use this website. And so why don't I use B courses? Because B courses is a little too private. It doesn't go on to the rest of the world, and I like all my lectures to be open to the whole world. Okay, that doesn't mean someone is getting the same thing you're getting without paying for tuition. Because generally what you have happening is people will look at the first few lectures, then after 3 lectures that's enough for them, and they stop. Right? There's something about getting the degree and credit that keeps you doing this. Whereas if you're not getting that, you stop after a while. But at least the stuff is online for other people to look at. It's also good for other professors to look at too. They take things and steal from my lectures as well, which I think is great. This is the way it should be, right? Okay, so let's go back to the other format here. Okay, so I said a couple things. So discussions don't start till next week. I sent an email out to everyone who was in the Wednesday discussion section telling you not to come to discussion, so hopefully you all got that and didn't try to show up for that. Discussions start next week. Labs don't start until the week after next week. Okay, so we don't have to worry about the fact that the Monday next week is a holiday, right? The labs will start with the Monday lab 2 weeks from now. Okay? In terms of enrollment in the class, like I said, this is a smaller 105 than usually is. I'm not sure why that is. I don't want to blame the 16s publicly in this lecture. I don't know what would occur. But I guess it's not that much smaller because there's a good number of people here. Maybe there's people just sitting in, seeing if they want to come in. I've let in all the concurrent enrollments already. And so there's already people, and there's still people signing up there. We don't know how the class will change, but it looks like they picked a pretty good room for this because you kind of fill up the room to the extent of, at least you can have a seat between everyone like that. Anyway, let's see, what else? Okay, so now let's get to the lecture topics. And what I'm going to do first is, first I'm going to say a few things about me, because it's always good to know who's lecturing to you, what that person's background is. Then we'll go through the course syllabus, which is the information on the course, and then look at the course schedule. If we have time, we'll talk about grading information and policy, and really if we have time, we'll get into actual material, which I'll get into review of signal types and maybe discuss a digital communication system that we'll go through. Usually this last stuff happens in the next lecture. So all right, let's say a few things about myself. And so there's another nice thing about this, right? I can leave the thing up on the left side and then start talking about things on the right side on this. And so a little bit about me. So I got my degree, my PhD degree, from this very university, UC Berkeley, but back in 1994. And after that, I didn't immediately become a professor. Usually what happens at universities, we don't hire our own. And that's certainly the case with Berkeley. You have to let the people go out first somewhere else, let them prove themselves, then if they're good enough, they can come back. Somehow I was able to come back. And so before that, I went to the University of Michigan. So in 1995, I was at the University of Michigan in their EECS department. And then I returned to Berkeley in 2006. And my research is microelectromechanical systems. And so if you don't know what that is, that's sort of using similar technologies to what are used for transistors, except to make mechanical parts. And so these are things that are on chip, but they actually move. And it turns out that when you can move something on chip in that size, there's a lot of cool things that you can do. For example, all of you have MEMS on them. In fact, all of you may even have my MEMS on them because it's a quartz. The oscillator in your phone, basically, is a MEMS-based oscillator. And there's a lot of them, actually, in your phone. Your cars have accelerometers, gyroscopes. Those are all based on MEMS. When you twist your phone around, when it goes from portrait to landscape, that's a MEMS part that's allowing it to do that. And if you drop your phone, you may not know, But before your phone even hits the ground, there's an acceleration sensor that picks up the fact that you dropped your phone because it knows it's free falling, and the phone actually prepares itself for the impact. Right? If it didn't prepare itself for the impact, things would go wrong. Okay, so there's a lot of things happening in your phone, just that phone, that are happening because of MEMS. But that's sort of my research area. This class is not about MEMS. This class is about another part of what I do in research, which is transistor level circuit design to go together with MEMS. It turns out that these sensors that we're using are a combination of microelectromechanical systems and transistor circuit design. That's what this course is about, transistor circuit design. And that's something that, again, I think all electrical engineers need to know that. Just to be able to call yourself an electrical engineer, but also just to be able to really understand some of the systems you'll be working with in the future. Now, still on my background, at the University of Michigan, I taught mainly transistor circuit design courses. They had no MEMS courses at that time because MEMS was a fledgling area. There weren't that many people working on it at that time. And so I taught only transistor level circuit design courses. At UC Berkeley, I've taught a mix of both of them. So I've taught 140, which is the course after this. It's a more advanced integrated circuit design. 143, which is semiconductor fabrication and processing. 240A is sort of the same course as 140, so it's being counted twice. W240A is a website-based course, so it's a web-based course that people have taken. 243 is an advanced fabrication course. 245 is the MEMS course, was the MEMS course until we changed it to 247B, which is about the same course. And then finally, W247B is a web-based course as well. So those are the classes that I should add 105 to this because I've taught 105 as well for the first time last time. And then in 2001, I founded a company called Desera. They're the ones doing MEMS-based oscillators, and they're the ones that basically are supplying, well, there's other companies that supplanted them, and all these companies got bought, have been acquired by that time, which means some people got rich. But you are now using that technology in all your phones right now. So I can claim, I'm pretty sure, every single one of you has a part that my research has created. And so that's a pretty cool thing. I think any of the Berkeley faculty could say that, though. Right? So that, I mean, you're at a pretty cool university because that's the case. Right? And so in mid-2002 to 2005, I went to Washington, D.C. and actually was a program manager in a funding agency. So there's a lot of money went out to MEMS research during that time that I was creating programs, putting money out. I think in the end of that, about $356 million of funding went into MEMS research at that time due to programs that were created. So the topics are right here, all sorts of topics: power generation, atomic clocks, gas analyzers, nuclear power sources, a whole variety of cool things and programs that I was able to create and manage when I was out there. So that's sort of my background. That's who's talking to you right now. But mainly what I want to teach you in this class is the circuit design part. So some of the physics to be able to understand how to design circuits. And not just the circuits you learned in 16. What we want to be able to get to are transistor circuits, which are somewhat different because transistors are nonlinear elements. And so I would say the takeaway from this class is not only that you're learning practical things like how to put transistors together to do a certain function, but also more fundamentally how to handle nonlinear circuits. Okay, and there's a technique called small signal analysis. Maybe you touched upon it a little bit in 16. Some of you may have, some of you may have not. It depends on which 16 you took, I suppose, who taught it. But in this class you will definitely get that. And the biggest takeaway, I think, from this class is how to analyze a nonlinear circuit. And that's something that you'll be able to take and use for almost all, for all sorts of things later on. A lot of things depend on that because this world is mainly nonlinear. Okay, so that's a little bit about me. Let's now go through the course syllabus. And for that, if you go online, you can grab that syllabus. That's in two places right now. It's with the lecture, for example. So if I go to the lecture page, which is somewhere here. Okay, so with these are the handouts right here. You can click on these and get to them. I can't right now because I'm not actually connected to the network here. But I have it up here. So if you clicked on that, you would get to this page right here. Okay? And so this is just a handout that's in PDF format that gives you all the information you need to know about this class. So if ever you have a question, if you want to contact some of the staff and that sort of thing, this is where all that information is. It's also on the first page of that website too, but this has even more information than that. And so just at the top, you can see me, you can see my coordinates, 574 Corey Hall. I usually take the time to try to explain to you where that is on 5th floor Corey Hall, because it actually is not an obvious place to get to. Because, I mean, you have a choice of taking 2 turns, this way or that way, and most people will take 1 turn because the hall is longer that way, and there's just a higher probability that the office is there. If you did that, that would be the wrong choice. It's down the shorter hallway. So I'll just say this, it's on one of the corners of 5th floor Corey Hall. Okay, so if you find yourself walking down a hall, you went the wrong way. It's at one of the corners. And if you go to all the corners, eventually you'll find it. 574 Corey Hall on 5th floor. Okay, you got my coordinates. This is my email address there. You can send me emails and it works, I suppose, but it's sluggish. And so the way that you should try to contact myself and staff, as you know by now, is through Piazza. Okay, so Piazza is being set up. It's already set up, but I did not put all of your emails into it yet. I will do that after the class today to make sure that I'm not putting in people that aren't really in the class and that sort of, to make sure that I grab all the people who want to be in the class. So that'll happen very soon, and soon you'll start getting some announcements through Piazza. This is also, as you know, a forum for you to ask questions about all sorts of things. Homeworks, labs, you could do it anonymously, whatever. We try to stay up with answering all the Piazza questions. But you have my coordinates here, and my office hours are going to be Mondays from 2 to 3, and then Wednesdays from 11:30 to 12:30. And that'll be in my office, of course, 574 Corey. So in the past, my office hours have been used heavily. Okay, before homeworks, before exams, that sort of thing. I like to get to know all of you. So absolutely don't be afraid to come to my office. By the end of the course, I know all your names and I know all your faces because people show up to my office. So do so. Okay, your TAs are also in this room right now, so I'm going to point them out right now. So Mr. Kieran Pillow is back there. You should stand, Kieran, so everyone knows. Yes, there he is. All right. And he actually, no, I'll do that later. He has the book that I didn't want to carry all the way over here, but he'll show it to you in a second. These are his coordinates. You can see up there, phone numbers, email address. His office hours are going to be Tuesdays 3 to 4 p.m. in 212 Corey, and then Thursday 4 to 5 p.m. in 400 Corey. Your homeworks will be due on Fridays. So that Thursday office hour, I bet, would be a popular one. Next TA, Ali and Mary, all in the back. They're all sitting in a row there, almost. So there's Ali. So these are his coordinates. You see his email, telephone number. Office hours are Tuesday 10 to 11 a.m., 212 Corey. Thursday 2 to 3 p.m. and 212 Corey. So you see another Thursday office hour in case you're the type who likes to procrastinate and get your homework done the day before. And then there's also Mr. Jeffrey Nee. Go ahead and stand, Jeff. And his coordinates, his office hours is going to be Friday 1 to 2 p.m., 212 Corey. He's not the others are 20-hour TAs. He's less, so that's why he has fewer office hours. But he's going to hold one of the lab sessions there. And so you know the lectures are going to be in here 4 to 5 p.m. The discussion sections, there's 2 of them. And the lab sections, there's 3 of them there. All of them have people in them. I guess we're going to stick with what's on the schedule right now. Hopefully there's no scheduling difficulties for anyone getting into a lab. But these are the TAs who will be in those labs. You don't know them, so just stay in your lab. Who knows how good or bad they are in the end. Actually, they're all very good. One of them actually is an award winner for TAs, but I'm not going to tell you who it is because I don't want to embarrass that person there. The course website, these are the coordinates for the website. You've already sort of seen it there. I mean, maybe the easiest way to get to it is to Google ee105, and that should take you to the up-to-date website. I already discussed office hours. So I've written up a course description here that you can read through here, sort of telling you why you should be taking this course, why it's important and that sort of thing. It all comes down to the fact that everything that we have these days is a combination of analog and digital electronics. And I guess, digital electronics has, there's been a huge revolution there. So most of the stuff you have is digital, But really a lot of it doesn't work until you understand the analog parts of it. So for your phone, just my voice that's going to you, that's an analog signal. So in order to process my voice digitally, your circuit has to first grab my voice. It's got to convert it to a digital signal. And the only way to do that is through an analog circuit, today at least. Okay, so it first goes through an analog circuit. That converts it to digital, and only at that point does the processing become digital. So all your cell phones that you're using right now, those are analog circuits at the front end. And the hardest parts to do in your cell phone are analog. And so if you want to think of what's the right expertise to have, you want the expertise that's hard. Right? You don't want the expertise that's easy, because then it's a dime a dozen. But if you go out and get an education in analog circuit design, and there aren't a lot of people who understand how to do that, you have a job forever. Because there will always be that interface from analog to digital if we want to do things digitally. Right? So what you learn in this class is going to give you a leg up on anyone who's not taking this class out there. I guess more information. I won't read through this. I'll let you read through that on your own time. But first let's talk about prereqs for this course. So the prerequisites are EE16A and 16B. Okay, and so for this matter, I'm going to assume when I'm lecturing that you're familiar with the following topics. So basic network theory. So RLC circuits, analysis methods, step and frequency response, poles and zeros, complex impedance, transient response analysis. You should have had this in your 16 courses or your equivalent. Ideal operation amplifier, circuit design and analysis. And for here, mainly you should have done at least ideal op-amps and that sort. Circuits there. If you haven't, we'll cover that in this class too, but we'll do it very quickly in sort of a review fashion. Some exposure to digital logic circuits, so inverter operations. So I understand in 16 they do discuss this, but they don't really show you that it's being done through a transistor. I think they just use switches. Or maybe they tried showing you a transistor. Did you see a transistor in 16? You did. Okay, did you understand the transistor in 16? Okay. You will understand the transistor in this course. That's what this course is all about. How many lectures did you have on transistors in 16? 2? Yeah, that's not nearly enough to really understand what's going on. Okay, and then basic electromagnetics. So fields and waves, potential, Gauss's law. I don't think 16 covers that, but probably in some physics course, at least in high school, you've probably seen that. And yet you need to take physics 7 as well. I don't know if you've taken that before this class or not, but that's not really a heavy need in this class. But when we start deriving things with device physics, that'll be very helpful for you to understand at least things like Gauss's law and that sort. How many people know what Gauss's law is? That's enough. The rest can learn by yourself. Okay, the texts. Okay, we have one required text, and that is Sedgwick Smith, Microelectronic Circuits, 7th edition. Kieran, there it is. Okay, why don't you turn around so they can see the thickness? Oh my God, right? Yeah, it's a thick book, but it's a darn good book. Okay, so out of all the books on this kind of material, Sedgwick Smith is excellent, I think, because you can read it. It reads very well. They don't leave any stones unturned. Okay, other books other books are great too, but sometimes they're great for people who already know the material. Okay, so I won't mention the book, but there's another book I think is excellent, but I think it's excellent only because I know the material. When I tried to use it for students, they hated it. Because what it did was it assumed a lot of knowledge, okay, that people don't necessarily know. Sedgwick Smith doesn't. Sedgwick Smith, at least I think, this may be my perspective still, but students from previous courses have said this as well. It's a great book. Okay, and so you need the book to really learn the material. So don't just listen to me. Okay, I'll tell you some really good stuff, right? But it's always good to learn it from another perspective as well, and that's where the book comes in. So I'm going to ask you not only to listen to my lectures and follow them, but also to read sections of the book. And I'll give you sections just to save you time, but in reality, the best thing is to read the whole book, which is a big book, so I know you're not going to do that. But if I assign sections out of a chapter, you'll understand them much better if you can read the whole chapter. Okay, I understand you have other courses and we're all pummeling you with all sorts of things, so you might not be able to. That's why I give you some sections. But the more you can read, the more you will understand of this topic here. So that's your required text. And I also understand that the book is very expensive, and so I don't know, some people might go for the used market. I know nothing about this, but it's possible there are things online. But these things online, a lot of them are going to be different editions of the book and that sort of thing. So when we assign you homework problems out of the book, and we will, so some of the homework problems will be stuff we made up, and some of them will be straight out of the book. And that's an important thing to do, just to make sure that because if you have to solve those problems, you're probably going to read the book. So that's going to help you to read the book and understand some of the stuff in the book. But if you have an old version of the book that has different problems, don't worry. When we put the homework assignment up online, we'll make copies of those problems from the 7th edition, so you'll see those exact problems. Okay? But you should get the book in some form, right? I guess for the publisher, buy the book. I know there's other ways to get the book, though. So there's other supplementary text that can be useful for you. We're going to be using a circuit simulator this semester called SPICE. And we'll give you some information on how to use that, but if you really want to get deeply involved with understanding how to use it inside out, there's a book by Tu-Cuong on SPICE, a guide to the circuit simulation and analysis using PSpice. We won't be using PSpice, but most SPICEs are the same. Incidentally, SPICE was invented here at UC Berkeley by a guy named Donald Peterson, who has since deceased. But that's where all this circuit simulation comes from. It comes from right here at Berkeley. So all the simulators out there, they may call themselves something else, but because Donald Peterson made his source code available to everyone, which is why it's a good thing to make things free to everyone, people were able to pick the source code up, change it a little bit, and then start selling it for a lot of money. Okay, which they did. But now there's a lot of SPICE out there and a lot of people can use it. So I think that's the important thing with being open with everything that you do, especially at a university. Right? Disseminate. Give for free. And that will be much more, have a much more interesting and impactful outcome than if you tried to hold it to yourself. Okay, another textbook by Jaeger, Microelectronic Circuit Design, not required, but it's a good textbook as well. It is less, it's more abbreviated than Sedgwick and Smith, so if you don't like to read too much, that's the text you could pick up and get the stuff very quickly. Gets to the point very quickly, but because he does that, maybe you'll miss a few things. There's also a text by Razavi that would be similar, I suppose. I don't have that written down here, but there's a couple references that you can use as well for this class. Now, reading assignments, problem sets, and the labs. I guess, let me go back to these things, but this is a good time to look at the actual schedule for the class. So this is the schedule. This is online as well on either the home page for the class or on associated with the first lecture. But this is what we're doing this whole semester. I'm telling you all the topics that we're doing week by week and on different dates. And so I think just to start, let me just say that any dates that have an asterisk next to it, we're not going to have a physical class because I'm going to be traveling somewhere. So far, there's 2 dates, October 4th and 7th, that are in that category. But before it's all said and done, there's probably going to be a couple more. Okay, on these dates, what I'm going to do is I'm going to record the lecture. At least I did this last time. Record the lecture and give it to you as a recording, and then you just watch the video for that, so we don't miss any of these dates. Now, when I do that, I often will go longer than the 1 hour, and that's to give you your money's worth. Right? I mean, come on, think of the tuition you're paying for this, right? You want more time than this of lecture, right? Not everyone wants that, but I'm going to do it anyway. Okay, just so that we can cover as much information as possible in this class for you, right? So when these asterisks come up, don't be surprised if we're behind on this. I catch up by adding material to that, okay? And there'll be more asterisks than that, so there'll be more opportunities for me to catch up if we ever get behind. And we probably will get behind at certain points. But so that's where the asterisks are there. Now, a couple other things that I should point out. We're going to have 2 midterms in the class. And so you can see the dates of the midterms. And so one of them will be October 11th. So I'm telling you up front when these dates will be. Okay, that's a Friday, and we're going to do that in the evening. Right? I can't think of a better way to spend a Friday evening than a midterm for an hour and a half. And it's really, literally, we already have the room reserved. It's going to be from 7 to 8:30. It's in a room down near the south side of campus. I forget the name of that, near the music building or something like that. But both exams will be in that room, 7 o'clock, 7 to 8:30. Maybe it goes till 9 if you want it to go till 9. Maybe not. It depends on, how well I can make that exam or so. But there'll be one exam October 11th. The second exam will be November 15th. And also the evening, same kind of deal there. Okay, so be prepared for that. Make sure that your schedule is open on those nights there. I'm telling you right now when these are occurring. Your final exam is group 13. We're going to stick with the group. And it's going to be Thursday, December 19th, 8 to 11 a.m. So that's kind of weird because this class is late in the afternoon and that exam will be in the morning. And so I don't know if you guys follow psychology and that sort of thing. Usually retention is best, or you perform best during the same time that you learn the material. So I don't know how this goes. They go from 4 to 5 to 8, but you're all in the same boat. So that's when our final exam is going to be. Okay? Now, in terms of topical coverage and a couple other things. So I really, the segue into this was talking about reading. Okay, and so these are the reading sections that I'm showing right here. So S and S means Sedgwick and Smith. I think that's the only thing that I have in there. No other textbooks in this. But this means section 1 to 1.3. If you want to read the minimum, that's the minimum. Okay, that's associated with the lecture that you're getting on this particular day. Okay, so try to stay up with the reading if you can. It's always best. I mean, there are some people who go only by lecture, but if you can also do the reading, you'll find that you will understand the material much better because you see it from two different perspectives. Also, you can see another column, homework. So this is when your assignments are due. So we're going to assign your first assignment the next lecture, and that'll just come online, and that'll appear on this day, and then it's going to be due a week after that, on Friday. And let me go back to this here and just point that out here. So the homework is going to be due by Gradescope at 12 noon on Friday. Okay? So 12 noon, that's the cutoff point. So Gradescope, I'm sure you're all familiar with that, correct? Yeah, so you're basically turning your homework in by PDF. You're more familiar than me, I suppose. Your TAs know it inside out. So we'll be using that to turn your homeworks in. Solutions will post on the web early next week. Okay, and our late policy is going to be 10% per day. Okay, so if you can't get it in on Friday, 12 noon, immediately that's 10% off. You can't make it by 12 noon the next day, which is Saturday, that's another 12% off. And so by the time the homework posts, which could be on a Tuesday the week after or Wednesday the week after, how many days is that? That's 1, 2, Saturday, Sunday, Monday, Tuesday, Wednesday. Yeah, that's like 60% off. So the best grade you can get by that time is 40%, but at that time, you can just copy the solutions, right? If you do that, I don't care. Because at least you're engaged in it, and you're actually, hopefully you at least look at the problem while you're copying the solutions. I mean, don't do this, by the way. But if you have to do this, okay, right? At least you're learning some of the material by copying the solutions. You're forced to look at the solutions. Okay, so that's our late homework policy for that. Okay, that's homeworks. Now labs, let me go back to the schedule here. So you can see the homework due, and you can see how many homeworks we'll have, right? We're planning 11 homeworks during this. Okay, we will not assign homework assignments when there's going to be an exam. So give you a break during the exam week for homework. And in terms of labs, you can see we have 6 labs total. So we don't have labs every week, and some of the labs are going over several weeks. Okay, so you have plenty of time to do these labs. Now, your first lab doesn't start until September 9th, Monday, September 9th. So you got a couple weeks before we actually start the labs here. Lab 1 will be review of passive networks, then 741 op-amp characterization, amplifiers, biasing is lab 4. And then starting with lab 5 and lab 6, these are no longer structured labs. So you'll have structured labs where we're going to release very specific instructions for you to do the labs. And those aren't yet on the website, but they'll be there soon. But these labs will be such that they're structured from labs 1 through 4, but lab 5 and 6 are open-ended labs. They're design problems. Think of them as projects, not labs. Okay, so you'll be given a spec, and you're going to have to use your knowledge of what you've learned in this class to make those specs. Okay, and it won't be necessarily easy, and it may not be fun while you're doing it, but by the end of it, when you've accomplished it, you'll feel a sense of accomplishment, definitely on this. You'll know that what you learned in the class really works. for what you're physically implementing. And you're physically implementing some practical circuits that could be used in actual circuits out there, analog circuits. Okay, I'll say more about lab later on, but let me go through some of the material in the class just from this. So the material is right here. So we'll have our lecture on Friday. We're going to talk about a comm system. I'm basically going to go through an actual comm system. So a microphone going into sort of an analog to digital conversion. When you're speaking into a microphone, the circuits that are needed to convert that to a digital signal that can then be processed by something else in the computer digital domain. Okay, so really what this class is all about, it'll be a picture of everything that we want to learn and be able to understand. After that, we'll start doing some review of some of the stuff you had in 16, sorry, the 216s. Frequency response, transfer function, impedance, Bode plots, amplifier models, input-output resistance. You've seen this before. Then we'll review ideal op-amps. You've seen that before. Negative feedback with those. And then we start some of the newer material, which is non-ideal op-amps. And maybe you've seen a little bit of that, but non-ideal means you can no longer assume the gain is infinity. You can no longer assume the input resistance is infinity, that sort of thing. And so we'll do that still using op-amp symbols, but you now have to take into account the fact that you've got all these non-idealities, finite gain and bandwidth. What happens when you put them in closed-loop circuits? Finite input resistance, limiting, slew rate, things that I don't know that you know what slew rate is, but you'll learn this in this class. Input offset voltage, input bias currents. The only non-ideality we're not going to cover is noise, which is a more advanced concept that you learn in, not even in 140, but at the graduate level, in say 240B, you'll learn your noise. Then from here, that'll be op-amps. We'll then start trying to get into transistors. Okay, and so what transistors really are, I said opening here, they're nonlinear devices. Okay, and I think most of the stuff you did in 16 so far has been linear. The resistor was linear, the capacitor, the inductor, and that sort. Transistors actually are nonlinear. And, you know, when you're trying to solve, your linear algebra works where? For linear problems, right? You learned linear algebra in 16. You loved it, right? The linear algebra part. Can't quite use it in some of the things here with a nonlinear circuit unless you play some tricks. Okay, so we're going to play some tricks that will allow us to go back to the linear algebra, but we won't use linear algebra in this class. You will not do Gaussian elimination and all that sort of thing in this class because no circuit designer does that. Okay, you learn that stuff in 16 because that's the way, and it's useful to learn because that's the way it's done in simulation programs. So SPICE, for example, when it takes a circuit, creates a huge matrix and it solves that. Okay, a circuit designer, if I did that as a circuit designer, I would never get a job anywhere. Right? Circuit design is more of an art. And that is the one thing you'll learn from this. The one thing I want you to be able to do by the end of this class is look at a circuit and immediately know what it's doing in just a few seconds. Okay? And it may look like a complex circuit. It won't be as complex as 140. 140, you'll be able to do that hopefully by the end with a circuit that may have 20 transistors. In this class, you'll be able to do that with a circuit that has maybe 4 or 5 transistors or so. Okay, you'll just look at it and you'll know exactly what it's doing. You'll know what needs to be changed to change its performance. This is what I want you to do, and you're not going to create a matrix to do that. You're going to look at it, you can do some back-of-the-envelope calculations, and you'll be able to do that. That's what I call circuit design by inspection. That is a powerful technique. Okay, there are people in this world who could do that. There are people at other schools who never learned this. Okay, so they'll take a class just like this. And then they'll try to get the job, and they'll show them a circuit, and they'll say, okay, let me draw this, let me make the matrix for that, let me solve this. And by the time the interview is done, they're still not done. Right? You, if you do well in this class, will just look at that circuit and say, oh yeah, this is what the gain is, this is what the input resistance is, this is what the frequency response is. You'll be able to tell immediately, and they'll be impressed like mad, and they'll say, okay, can we give you a higher salary? Right? So that's what you really will learn in this class here. And so in order to learn that, we have to get around how to model nonlinear elements. So we'll talk about nonlinear elements, diodes, junction capacitors, MOS transistors, bipolar transistors. These are all nonlinear elements. And before we can even get to the modeling, we have to understand the physics. Okay, so the physics is the part that is going to be tough for me to really cover in full because there are other courses that do a much better job of that, like 130 will do that. So I'll do my best to give you the basics of the physics. And by the end of that, you'll learn how transistors work. You'll learn what they are, how electrons are moving. Do you know what a hole is? Okay, one person knows what a hole is. Did you learn holes in 16? No. Okay, some people may have seen holes from somewhere else. But yeah, you may be thinking, what the heck is it? Why would anyone use a concept like a hole? Well, a hole is just where an electron is not. Okay, and so that you'll learn that later on, and both of those come into the picture of how transistors work. Simplified picture. You can go much more detailed where you start talking about physics and statistics, quantum type stuff, which I could try to do, but I probably will not try to do that because very few will understand that. I'll keep it at a level where you can understand how the devices work, because that's what you want to do. You want to understand the devices, and then once you get that basic understanding, you can model it. That's what we want to do. We want to model the device, and that's what we'll be doing here. So down here, transistors, well, sort of parameter independent biasing, small signal analysis of circuits. And we'll talk about general circuits, and we'll talk about transistors here. Once we have this small signal analysis technique, that's a technique that allows you to analyze a nonlinear circuit in a linear fashion, which means it's much easier. But again, you're not making matrices. You're just going to be looking at the circuit, maybe writing down a few equations here and there, but you'll be able to get to it very fast. We'll look at things like frequency response, gain, input and output resistance, that sort of thing. And then we'll talk about sort of rudimentary how to create an op-amp. So you'll be playing with op-amps in the beginning. You don't know what's inside an op-amp. At least most of you don't know by this time. But by the end of this class, you will see what's inside an op-amp. The way the transistors are put together, how they're structured to create that function. And op-amps are basically used for everything that's out there. You can look at any circuit out there, and op-amps are there. And so I guess there's more stuff associated with that. Then finally, we'll revert from analog and start talking about digital. Okay? And so with digital at the end, we're not going to spend a huge amount of time in digital because there's not that much time to do that. This is sort of prep for a course like 151, which is the course that another course that everyone I think ought to take as well, because that really helps you understand how to build a digital circuit, which is very much system level design there. But we'll talk about CMOS inverters, which you've seen before, I think, in 16, but not with the transistors. So we'll now put the transistors in, and that will allow us to do a much more accurate analysis as to what the propagation delay is going to be. We'll look at some oscillator circuits, like a ring oscillator, very simple oscillator, and then driving circuits for wired capacitance. And then at that point, the course ends. So that's sort of the content of the course and what you'll be learning as you go through this. I guess at this point, I'll stop and just ask any questions about anything in the class. Logistics? Yes?
So Thanksgiving week, there's no lab at all, right?
Yeah. I mean, there shouldn't, well, let me see what I'm saying here. Yeah, that's right. So Lab 6, that is a project that just keeps going. And so with Lab 6, you're not even showing up to the lab necessarily on your lab day, because part of it's going to be simulation. So it's both simulation and you have to hook it up on a breadboard to make it work. So in the beginning, do you even show up to the lab? Maybe you do, because your TA will probably have some pointers on how to design it. But the second lab associated with that, maybe not. Maybe you're busy simulating. Maybe so, because that's free help from your TA. But then the last few labs, you'll definitely be there, and you'll probably be there even more than your labs. We'll open up the lab. You'll have access to the labs, and you'll be able to go there anytime, pretty much, as long as there's not another course using our equipment during that time there. But you'll want to use that by the end of the course. Yeah. So those last labs will consume a good amount of time. Okay. Any other questions about scheduling? I'm not done with this. I want to talk about the labs in more detail, but just at this juncture. Yes?
How are the homeworks graded?
So the homeworks are going to be graded. So you're going to turn them in by grade scope, and you have readers who will grade them, basically. And so, right, they'll mark them up. Do they mark them up? You guys tell me. Yeah. Okay. Yeah. Did you have another question? Did we answer your question, or is it?
Yeah. Are there regrades?
Are there regrades for the homeworks? I suppose, yeah. Yeah, you can have regrades in that sort. You might not want to when I get to the end of this, because the homeworks are only worth 10% of the grade. in the end. And that I do that because I want to encourage you to do the homeworks by yourself as much as possible. In the book, we'll even assign some problems in the book where they have the solution in the back, right? And so we'll even do that, the numerical solution, not the way to do it, right? So the reader will look to see whether you've done it correctly in order to grade it. But for the homeworks, I want you to do them, right? The spirit is to do them. Because if you don't, you get nailed on the exam and the labs and that sort of thing. Okay? Any other questions? Logistics? Okay? So I'm going to keep going here because I need to talk about the labs. So let's do more on the labs. So when you do the labs, the first 4 labs are very well structured. And what I mean by that is you have a pre-lab. So there's preliminary discussion and problems. When the lab comes up online, you'll see a pre-lab there. They'll tell you exactly what to do. You're going to have to do some calculations on your own and fill in some blanks in the pre-lab. You have to show up to the lab with that sheet in there where you filled in all the numbers. And the rule is, and I hope my TAs stick to this rule here, is that you come to the lab and you're done with your pre-lab and you can't start your lab until your pre-lab has been checked off. Okay? So you have to have that pre-lab done. You have to come in with it. Your TA will check it off, and then you can start physically doing your lab. After you're done physically doing the lab, then there's a lab report that you put together, which are general questions. You don't have to make a report for the first 4. You're just answering questions on a handout sheet that we have for you. For lab 5 and 6, there's going to be a report. You actually have to write a report in prose, put figures in it, make it look nice, because that's part of your grade on labs 5 and 6. Okay, so for labs, you will be partnered up. So 1 through 4, you will have a partner in the lab. Lab 5 through 6, I guess last time we had partners too. I think that's the best way to do it. But you turn in your own lab reports for all the lab. Okay, that has to be your work, and all of those get graded. The labs are worth a lot more than anything else in the class, and we'll get to that in a second. But you can read all this stuff about the labs here. But let me skip a little through that and get to this. So the grading policy for the labs are going to be technical content 90%, document quality 10%. Right, so things sort of have to look nice by the time they come in. For the first 4 labs, where you actually have pre-labs, it'll be 30% pre-lab, 60% actual lab reports. Okay, so the pre-labs are very important there. Now, in terms of overall points for all the labs, you can see for the first 4 labs, they're all worth 100 points each. Okay, but then when we get to lab 5 and 6, which are really projects or design problems, these are worth more. 5 is going to be worth 200, 6 is going to be worth 300. So you can see that those 2 together outweigh all the other labs by themselves. Okay, that's because we're putting emphasis on the projects there. The total is going to be 1,000 out of all of these there. Okay, so those are the points you'll get for your labs. You'll see up here there's 100 points for lab performance as well. So what this means is your TA is watching you to see how you're doing your lab. I'll let them say more about how they want to grade that there. But there's sort of a performance thing, right? You have to be involved with your lab. You don't want to be the person who doesn't do anything and your partner does everything and that sort of thing, right? So get involved. Everyone needs to be involved with all aspects of the lab in order to do well there. Midterms I already talked about. They'll both be closed books, so no books or other written material. I'll let you have a calculator. So that's the thing I'll mention. If you do not have a calculator, buy one now. They're very cheap, I think. I mean, who has a calculator these days? That's usually that comes back to me because you can just use your phone for that, but no phones during the midterm. So you do have to physically get a separate calculator. You know, you want it to have at least a sine cosine function and that sort of thing. You should not have a calculator that, it's going to solve equations and that sort of thing. Although I don't think it matters in this class that much. Was that your question or what? Yeah, I think a scientific calculator is fine. Yeah, what did you say? Full functional? Or? For function. What does that mean? Oh, well, I think you want like 1 over x. You want exponentials and that sort of thing. What do you mean by scientific? You mean graphing and that sort? Yeah. Yeah. No, don't get a graphing calculator. I mean that will waste more time. That will hurt you more than help you on the exams. I'll tell you that. Yeah, so stick with a simpler calculator if you can. Final exam, that's going to be comprehensive, covering all the course material. But you know what happens with that. Usually it's going to cover more towards the end of the course, that type of material. Now, let me look at the time here. Computer accounts. So you know how to do this, I think, but if you need a computer account, go to this website here, and I think just follow the procedure there, you'll get that account. Now, if you're in concurrent enroll, so everyone who's enrolled as a Berkeley student, you'll be able to get in with no problems. If you're concurrent enrollment, let me know if you have an issue. I don't think you will, but you might with this. But if you do, let me know, and we'll get that fixed for you. Again, you'll all get access to the lab too, and that'll happen within a couple of days. You don't need to get in there. The lab is 125 Corey Hall, but you don't need to get into there anytime soon. But that's the card key access. Here's the grading policy right now. So problem sets 10%, like I said. Okay, they're not going to be worth that much. That's to encourage you to do them by yourself. But if you can do them by yourself, if I could give you no solutions, that actually would be the best thing for you. Because then you'd have to think for yourself, am I right or wrong, and you'll never know. That's the way the real world works. But this is a class, so we'll give you solutions. But try to do them, as much as possible by yourself. Lab projects, so there's the lab. So the lab and projects together, that 1,000 points, in respect to the whole class, that's worth 35%. That's the biggest percentage in the class. Okay, so pay attention to those labs. The midterms, 15% each, so 30% total for the midterms. The final exam, you can see 25%. Okay, now since I have a little bit of time left, let me just go through the grading in the class. And we'll do this again once we hit the first midterm, well, after the first midterm. But the way I do this is I calculate a z-score. So I don't know if you've encountered this before, but what a z-score is, basically taking the grade that you got on any particular thing, subtracting the average, dividing by the standard deviation. What this does, it puts everything in the perspective of zeros and ones. So if this, after calculated, your z-score is a 0, that means you're exactly average. If it's a 1, that means you're one standard deviation above the average. If it's a -1, that means you are one standard deviation below the average. Okay? And so I will calculate a z for every component of the course, for homework, for the midterms, for the finals. And I will then use this formula here. Well, no, that's the lab z right there. And then I'll use this formula right here, which is all those percentages I gave you, to calculate your final z. And then what that final z becomes by the end of class, so it decides what your grade is. Now there's also other things, right, like if you ace the final, like if you didn't do that well in the 2 midterms, but then suddenly you ace the final, I will pump you up a grade just because of that. Now in terms of what is a 0, what grade is a 0 in this class, so that depends on what the Gaussian plot looks like. Sometimes it's an extended one of that sort. So I can't really tell you that much, but you know what it is nowadays for an upper division class. That's going to be around B+, sort of B and B+ or something, right, for a class like this, upper division. Okay? And so we can talk about this later on when we get to the midterm. Everyone wants this. And so after the midterm, what I do is I show you your z-score, so you know where you stand at that point after the midterm. And I'll do that for every midterm and before the final as well. Okay? So we're out of time, but if there's any residual questions, please ask. Anything? All right. Well, then I'll see you on Friday. Let me first stop this here, because sometimes I forget to